Hello and Assalamu alaikum guys. In this particular video, we will be talking about circular motion. To be able to understand circular motion, it is very important to understand the concept of acceleration. Now, we define acceleration as change in velocity upon time. So for a body to be accelerating, the velocity must be changing. If we take an example of an object moving on a circular track with constant speed, we have to identify that it is still accelerating. Because although if it is moving with constant speed, but due to continuous change in direction of motion, the velocity is changing. And hence, that is causing the body to accelerate. We call this acceleration as centripetal acceleration. The velocity is changing and there is an acceleration, and that acceleration always acts perpendicular to velocity and inwards of the circular path. According to Newton's second law, resultant force is equal to the product of mass and acceleration. If there is an acceleration towards the center, there must also be a resultant force acting towards the center. That resultant force is called centripetal force. So, what we need to understand is that even if an object is moving on a circular path with constant speed, the velocity must be changing. That velocity is changing because of continuous change in direction. And as velocity is continuously changing, so body must be accelerating. This acceleration is called centripetal acceleration, which acts towards the center. And the force that acts towards the center is called centripetal force. We can have different examples of bodies undergoing circular motion and experiencing centripetal force causing centripetal acceleration. For example, if an electron orbits around a positively charged nucleus, it goes in a circular path, it continuously accelerates because of continuous change in direction, and the force acts towards the center. This is called the centripetal force. Similarly, you have examples of masses orbiting around other masses, like planets orbiting around Sun, Moon, or satellites orbiting around Earth. They are also undergoing a circular motion, and they experience the force towards the center, which is the centripetal force. So, in different situations, the centripetal force, which is the resultant force towards the center, is provided by different sources. In case of electron orbiting around a positively charged nucleus, the centripetal force is provided by the electrostatic pull. In case of moon orbiting around Earth, the centripetal force is provided by the gravitational pull. Similarly, if a cyclist is taking a turn at a particular point and going in a circular path, then the centripetal force would be towards the center, and that would be again provided by some source. In this case, that is the force of friction. One more thing that you need to understand is that if the acceleration is not there, if the acceleration stops acting, there is no resultant force towards the center, then the velocity would stop changing. In that situation, the object will move with constant velocity in a straight line. That is, if the centripetal force somehow vanishes all of a sudden, then the object would move out of that circular path tangentially in a straight line. So guys, let's have a look at some of the past paper questions. In this question says the diagram shows a cyclist leaning over in order to cycle around a corner. Which force is necessary to maintain the motion around the corner? So he's bending in this direction towards his right, so there must be centripetal force towards the center of that circular arc. Hence, the centripetal force acts in direction A. That is the force necessary to cause the circular motion. In another question, it says a body P moves in a circle around a point S. A force F keeps it moving in a circle. what happens if the force suddenly disappears? So F is the centripetal force. If it disappears, it'll stop accelerating and it'll move out with constant velocity. So it will move out in a straight line. The answer in this case is going to be D. Now in this structured question says, figure shows the planet Venus orbiting around the sun in a circular orbit at constant speed. And we know that despite it is moving at constant speed, it must be accelerating because it is experiencing a continuous change in direction. A force acting on Venus keeps it moving in a circle. State the name of this force and the object that causes it. So it's the gravitational force. Providing centripetal force. Exerted by sun. In the next part, it says on figure draw an arrow through Venus that represents the direction of its acceleration. So we know that the centripetal acceleration acts towards the center of the circular path. So this is going to be the direction of centripetal acceleration. Then it says the size of the acceleration is 9.7 times 10 power minus 3. The mass of the Venus is 4.9 times 10 to the power 24. You have to calculate the size of the force. So we know that according to Newton's second law, F equals ma, the mass of the Venus is 4.9 times 10 to the power 24, and its acceleration is 9.7 times 10 to the power minus 3. I calculate it and I'll get myself the resultant force. It's coming out to be 4.8 times 10 to the power 22. That would be the size of the force. As time passes, the planet Venus moves a considerable distance around the circular orbit. State why no work is done by the force acting on the planet as it moves. So work is the product of force and displacement in the direction of force. So if force and displacement are parallel, that will cause the work to be done. If I take example of this object moving on a horizontal surface, the normal reaction and the weight would have a zero work. That's because motion is perpendicular to these two forces. So there is no displacement parallel to force. If there was any displacement in direction of normal reaction, I would multiply that with normal to get the work of normal. But in this case, since it is moving perpendicular to normal reaction, the work done of normal reaction would be 0. Similarly, if it is moving perpendicular to W, the work done would be 0. Similarly, if we take this particular example where Venus is orbiting, the force is constantly acting perpendicular to its motion. So no motion occurs in the direction of force, and hence the work done would be 0. Since force always acts perpendicular to motion, hence no displacement occurs in the direction of force. So its work must be 0. I mean, another way to look at it is work is the product of force and displacement, which is parallel to it. So in this case, the displacement parallel to force must be 0. Thank you so much, guys. If you liked the video, please do click on the like button and subscribe to my channel.